Yeah. What's going on, guys? Graydon here with Bavarianautoclinic again, and today we have this E28 85 535i. It's going to be a 5-speed manual, and it was brought to us for a crank no start condition. So it just crank and crank and crank, but the motor wouldn't fire. So we're going to take you through the steps that we go through in determining faults in a M30 powered BMW that runs on a 1.0 Motronic unit. So we'll kind of go through, we'll start from the easiest stuff where we start at, and then we'll work our way to the hardest stuff. So we'll kind of tell you what to first look for, and then all the steps right to the end. So stick around. Alrighty, so we're just gonna take this air box off to show you guys a little easier what we're talking about. Screw this hose clamp, unplug the connector from back here. Should just pull straight off. Get out of the way. The first steps that we need to take is determining whether the vehicle has no fuel or no spark. And so the first thing I always do is easy check for fuel is to come here, pull this return line for the fuel rail off, and I'll just put it in a little water bottle, crank it over, and if fuel comes out, then obviously the pumps are working and pumping fuel through the fuel system, through the rail, into the ejectors, all that sort of thing. So we know fuel's most likely not an issue. We have fuel. So then after that, we're gonna go over here and we're gonna test spark. We'll pull the wire out, pull the plug, insert the plug back into the wire, and just set it against the cylinder head here and crank over, and somebody else will watch and see if there's a spark coming from that spark plug, because we're trying to ground out the spark plug. And in this case, there was no spark. We had fuel, but no spark. So going through the next steps here, I wanted to eliminate the distributor cap and rotor. So I went ahead and took the number 1 lead going to cylinder number 1, took it off the distributor and put it straight onto the coil, removing the what is called the king lead, which is the lead from the coil pack to the distributor, and see if you have spark there. In our case, we did not have spark. So I knew for some reason the coil was not firing when it should be. So the next easy thing to test is to make sure that the coil is good, has the correct resistance, and is getting power when it should be. So key on, you should pull your multimeter out and put your positive lead here and ground out your negative lead somewhere else. I usually use like a nut on the valve cover here. And if it has 12 volts, then that means the coil pack is getting power where it should be. So in this case, yes, our coil pack was getting power. Then the only other option is the coil pack's not getting ground, which the ground is fed by the ECU here. So for some reason, the ECU is not grounding out the coil pack and telling it to fire. So we need to determine why exactly that is. And we also, in this case, need to make sure that the coil is good too. So we went ahead and pulled the lead removed from the coil pack, and we measured resistance from this. This is called terminal 15. This is gonna be terminal 1, and this is gonna be terminal 4. We measured resistance between terminal 4 and terminal 15, and I believe that should be 6,000 ohms, plus or minus a little bit here and there. And then the resistance between the positive terminal and the negative terminal, I believe, should be 0.5 ohms. And both of those were close enough to those values to where I didn't think the coil was bad. If the resistance values are off the charts, if they're wildly different, then I would say the coil is probably bad. In this case, the coil was good. So for some reason, that DME, the Motronic unit, is not telling the coil to fire. So either the Motronic unit is getting all the inputs it needs to tell that coil pack to ground, and it's choosing not to because there's an internal fault in it, or it is not getting all the inputs it needs to correctly say, hey, yeah, we're gonna ground this coil out and make it fire. In that case, we need to figure out exactly why. So we wanted to make sure that the Motronic unit was getting power, and over here, we have our main Motronic unit relay right here. If this relay isn't in, the Motronic unit is not going to power up. So we tested that. We actually found that the relay in there was an incorrect relay. It was, let's see the diagram here. So how this relay is supposed to correctly work is that 85 right here, that's going to be your constant ground. 30 here is your constant power, so that'll have 12 volts no matter what. And so when you turn the ignition on, 86 gets 12 volts, pushes that little lever, and connects 12 volts to both of these 87 terminals. So this is what the incorrect relay is. The incorrect relay was giving power to one of the 87 pins when it should be giving power to neither of them. And then once this relay is activated by the 12 volts from 86, it was moving itself to power the other 87 when we need both of the 87s powered up when the ignition is on. So we were really confused because the DME was not powering up when it should be, but we were getting power to the relay was clicking, everything like that, and I pulled the relay out and I looked closer and I was like, somebody swapped out this relay for the incorrect one. So once we determined that, we purchased the correct relay, put it in, and now the Motronic unit was getting power. And an easy way to tell that if the Motronic is getting powered up is, there's two ways. When you have the key on, the idle control valve should make a little humming noise and vibrate when you touch it. So let's see if I can demonstrate that. You can kind of hear it here. See if I can hear that humming noise, and then you touch it and you can feel the vibration. So it's a good indication that the Motronic unit is powering up. And another good way to test with your multimeter is to pull one of the connectors that connects to the injectors and put one of your leads here. You're testing for 12 volts and ground it out here. And if you have 12 volts with the key on, then the Motronic unit is powering up. So in that case, that would mean that the main TMA relay is correct. It's good. From there, what do we do next? Another good way to determine whether or not the vehicle is getting spark is to look at the tachometer when you're cranking it over. If the needle moves at all, then that means the computer is telling spark to activate. The wire coming from the Motronic unit to the coil pack, the ground wire, is the same wire that goes to the tachometer to give it the signal to move. So when we're cranking this car over, it did not have the tachometer did not move at all. So another good indication that you don't have spark. So we went to the ECU. Always, the Motronic units are very sensitive, so you cannot unplug them while the battery is still connected. You must disconnect the battery and then unplug it. Same for plugging it back in. You don't want to shock the system at all. That could lead to a Motronic unit failure. So basically we pulled the connector off. We put our multimeter in. We made sure that there was continuity at all four grounds. We made sure that pin 35 and 18, those were 12 volts with the key on. That was good too. And then we went through and we tested. You could do this at the connector to the speed or the reference sensor as well. But we tested the pins at the ECU to make sure that the reference and the speed sensor were sending their signal to the Motronic unit, and they were. And the resistance for the reference and the speed sensor is supposed to be 960 ohms plus or minus 96, and both of which those sensors were giving off the correct resistance between pin 1 and pin 2. And the resistance for pin 2 and 3 and 1 and 3 is supposed to be like 100,000 ohms. It's not gonna put a reading on your multimeter, basically. So we did also do one more test for the speed and reference sensors to make sure they were absolutely good. I went to pins 1 and 2 while I had somebody else crank the vehicle over. We're looking for 0.7 to 1.4 AC volts, and both of those sensors gave off good readings for both of that. So the pin on the flywheel that the reference sensor looks for means that was present, that wasn't absent on the flywheel, and both of those were picking up the signals from the flywheel that they should be. At this, we were kind of scratching our heads. We were like, we just went through the whole checklist and we didn't find anything wrong. The only culprit, the in between all these inputs and the output going to the coil, is the Motronic unit itself. So we decided to pull the Motronic unit apart, and we found 2 out of the 3 solder joints were cracked going to the transistor, I believe. Anyways, and the actual board had overheated because the copper that had melted and started kind of smearing down the board. So at that point, we were like, okay, this needs a Motronic unit. You know, this unit was original to the car, you know, almost 40 years old. And so we got a rebuilt unit, put it in there, and this thing fired right up. That's kind of your no spark checklist for a 1.0 Motronic system with an M30, specifically, you know, E24s or E28s, I believe would qualify this, or I guess this would also apply technically to the 1.1 Motronic systems. It'd just be the only difference between those is the speed and reference sensor is combined into one sensor, the crank position sensor, and that's on the front of the motor on the 1.1s, I believe. Maybe it's on the back. Either way, the only difference between the 1.1 and the 1 is that instead of a speed and a reference sensor, two different sensors, they combine that into one sensor, the crank position sensor, which has a different resistance reading. It has, I believe it's 540 ohms. So if you're testing for that on a 1.1, be looking out for that, not for 960. So yeah, put the car back together, did a couple little other things, fixed some oil leaks, that nature. We had some water intrusion leaks in the cabin, so kind of waiting on those parts. But the good thing is that this thing runs and drives awesome now. Fires right up, runs pretty good. So we're gonna hand it back to the customer, and the customer's super happy. So that's gonna be all here. So, that's gonna be it for this video. Just a short video for you guys. Quick diagnosis. Wrap that one up. Customer's happy, car's running good, and yeah. Hopefully we'll have some more E31 content here. Trying to source the correct headers so we can finish this exhaust and get it on the road. But besides that, that's gonna be it for this one. We'll see you guys next Friday. Like, comment, subscribe. You know what to do. You're done! Welcome back. Got another video for you.
I was moving the camera all about. And you were...
What's going on, folks? Got another banger for you. No?
Okay, you ready?
Yo, what's poppin'?